Kia ora, guys. I thought I'd do a little follow-up video from the lab yesterday to look at the results of our cell size and diffusion experiment using the agar cubes. It turns out we accidentally used gelatin instead of agar, which is why those cubes just dissolved in the vinegar and it was a mushy mess. Nevertheless, through your innovation, we've still managed to get some data and the experiment still works. So let's have a look here. I've put the mean in here. So in Excel, you can calculate a formula by starting with an equal sign. And this tells Excel that you are trying to calculate a formula rather than just typing in text. So we go equals average, and then in the brackets, you can specify the range of cells that you want it to take the average of. So we've got this whole row here. The mean or the average is 1. Remember, this is the length of pink. So we had a length of 1 at the starting point because the whole block of 1 centimeter was pink. But then as time goes on, it drops because the outside is getting clearer, / it's dissolving in the vinegar. And it drops down to 0.1. Likewise, for the 2 centimeter cube, it starts off at 2 centimeters of pink and that drops to 1. For the 3 centimeter cube, it starts off at 3 and drops to 2.1, 2.2. So we can see that is going in the right general direction. Okay. Now, if we go over to the next tab, the diffusion percentage tab, here's where we do the calculations to convert that into the percentage of diffusion from our pink length to the diffusion percentage. So we've calculated the surface area of these cubes. The first one was 6 because it's 1 by 1. So one face of that cube is 1 centimeter squared. And then there are 6 different sides to a cube. So you multiply it by 6. And you get 6 centimeters squared. For a 2 centimeter cube, where all the dimensions are 2 centimeters, you end up with a surface area of 24 centimeters squared. And for a 3 by 3 by 3 cube, you get 54 centimeters squared. And then these are the volumes: 1 centimeter cubed, 8 centimeters cubed, and 27 centimeters cubed. If you look at the ratio, how the ratio is changing. So in that small cube, you've got a surface area to volume ratio of 6 to 1. For the bigger cube, the 2 centimeter cube, it's 3 to 1. And then in the biggest cube is 2 to 1. So look how that surface area, there's lots of surface area per volume in a small cube, but it drops to being a lot less for the volume in a bigger cube. So that was a key point to take away from the lab. Here we've put in that the average width of the pink agar for the different time points. So averaged across the groups. This is taken from that other tab, and you can see this equals, see how it says pink length? That is taking its reference from the pink length tab. It's saying, look there and look at cell M3 to get the value for this. So that's just another kind of formula you can do. I can click somewhere, I can go equals, and then I can go to another tab and click a particular cell like this one, and then hit enter. And you can see it's taking that value from the other tab. Equals pink length M47, it's referencing. So that's what I did here. I just grabbed those mean values from the other tab and put them in. Okay, and then from there, the volume of the pink agar, you measured one length of that pink. If you measured the length, you times it by the height and width, which is all the same. And that gives you the volume of the pink agar. But what we really want is the inverse of that, which is the volume of diffusion. So what we can do is we can take the volume of the cube, the whole cube, and subtract the volume of the pink agar, and what's left is the difference, okay? And you can then use that to calculate the percentage diffusion. So I've just used these little formulas up here. You can see how in Excel, you write it out slightly differently. You use a little asterisk for multiplying. F4 times F4 times F4 means the value in cell F4, which is 1. So it's 1 times 1 times 1 gives you 1 centimeter cubed. What did we actually see? Let's have a look. The moment you've been waiting for. Here are our time points. Here's our different cube percentage diffusions. And I just did this. I selected it. I clicked on Insert, Scatter Plot, and chose this one here. Okay. So what can we see? I'll just delete that one. Look at the slightly bigger one. So the 1 centimeter cube much more quickly shot up to a higher level of saturation until it got to 100%. So it got 100% saturated with the vinegar. Whereas the diffusion was a lot slower for the 2 centimeter one, and then even slower for 3 centimeter. Not sure why this point actually went down. I suspect that's some error due to the cubes becoming mushy. But in general, we're seeing that kind of plateauing shape, which some of you predicted. And it makes sense. The biggest cube is taking the longest for the vinegar to diffuse towards the center. How can we make this graph look a bit better? So think about, if this is a percentage, there's no point at going up to 120%. So how can we make sure that it stops at 100%? If you double click this, here you can set the maximum to be 100. That's a bit more logical. We could get rid of the chart title. We could clean up the lines on it. Maybe we don't need the lines. We could have calculated the standard error, the error bars, but we didn't really have that much data, so those error bars would probably be pretty huge. We can change this time axis here to, let's say, instead of having units of 5, we could do units of 2. And say maximum of 20. So there we go. Now it's going up in the actual time intervals that we measured at, which is more intuitive. We could add axes. You can always add chart elements from this button here. So we can go axis titles. Yeah, let's add a primary horizontal title. You go time in minutes. And we can go into primary vertical, say percent diffusion. And there, it's starting to actually be an interpretable graph now that is useful. And you can do more. You can change the size of the text and the font and the colors and help to continue making that look pretty. All right, I hope that was helpful. And now you can see the results of your labors yesterday. And I'll see you sometime soon.